I ran this agent 50 times at temperature 0. A few of them disagreed, and this is the simplest agent possible. You know that feeling when you run a demo once, it works and you just believe it. That is how every agent tutorial ends. Nobody runs it 50 times. So today we're building the whole thing from an empty file and then we're measuring what it actually does. So an agent is basically a while loop. You send a message, the model asks for a tool, you run it and you hand back the result. That keeps going until the model stops asking. Everything else in a framework is scaffolding around the 4 steps. Writing the loop is the easy part. Knowing whether it worked is not. Alright, the hardness is the other half of this. It checks 2 things on every run. Did the final answer match and did both tool calls fire in the right order. We are not using a judge model or an evaluation service. It is plain Python asserts and asyncio.gather runs the whole thing 50 times. But the best way to learn it is to write it. Alright, you know the loop and you know what the oracle checks. Let's write both from an empty folder and find out what the 50 runs actually say. So the whole project requires just one package and that is Anthropic. After that we specify the Anthropic API key and we also create the fixtures folder. In the fixtures folder, we have 3 text files, which are the reason this test means anything. Only the nodes.bit text file contains the word checkpoint and it shows up exactly 4 times. Notice that none of the other 2 ones mention checkpoint anywhere. So when we ask this question, the expected result is 4 on every single run. Alright, these 2 functions are the only real work that the agent can do and both are boring on purpose. Task sits up on the top, so the hardness imports the exact same string later. Notice that count matches takes content and not a file name. It cannot open anything, so the model has to read a file first and pass the text through. That is what makes the task 2 steps instead of 1. Both tools return a string, and that actually matters. 2 results have to be text, because if we hand back an integer, the SDK will reject it. And count is also case sensitive here, which is going to come back in a minute. So the model never sees your Python, it only sees these descriptions and they're the entire contract. My first version of count matches said text you already have and the agent fed it the file names instead of the contents. I got 50 failures out of 50 runs and the model was right. So read file now says the files live on disk and names them. And count matches says the content comes from read file and never a file name. This is the other half. The model sends back a tool name as a string and we look up the real function in that dictionary. Alright, this is the entire agent. We send the messages and the model either answers or asks for a tool. That while loop keeps going until stop reason stops saying tool use, which is the part that makes it agentic instead of a single call. Notice that we append the raw response content straight into the messages. The model needs to see its own tool call on the next turn or it has no idea what it just asked for. And when the model is done, we pull the text out and return it with a trace. So this block is where the tools actually run. We walk the response content and we run every tool use block and record it in trace at the same time. The ID matters here. Each tool result carries the tool use ID it belongs to and if you drop or mismatch it, the API rejects the turn. All the results go back in single user message, not one message each. And that trace list is doing a quiet work. It records the name of every call in order and the harness reads it later to decide whether the agent took the right path. The run once Python file is only 4 lines and it only exists because we want to keep the agent.py file short and we want it to contain only the agent definition. You can run this file every time you change a tool definition. Let's see what we've got. As you can see, the answer comes back as a 4 and we can see that it read multiple files and it invoked count matches once. So here's the thing that makes this an evaluation and not a demo. The oracle checks 2 independent things. First, the answer has to match 4 exactly. Second, the trace has to start with a read and end with a count. That second check is the one people skip and it catches the run that guesses 4 after reading the file without ever counting. It reached the right answer down the wrong path and that still fails. And notice how strict the string compare is. If you normalize harder, some failures quietly turn into passes, so make that call on purpose. Asyncio.gather fires all 50 runs at once and that is the only reason this finishes in under a minute. We wrap each run so a crash becomes fail error with the exception name untouched instead of killing the whole batch. Notice that we print the answer at the trace for anything that is not a pass. That one line is what turns a red number into something you can actually fix. If you're on a low rate limit tier, 50 concurrent runs might give you back an error, so drop it to 10 at a time. Counter at the end prints the split. Alright, this is the moment of truth. Let's ask the same question 50 times with temperature of 0. As you can see, the 50 questions came back green, so the agent was never the flaky part. Both times this failed today, my 2 descriptions were wrong and the model was reading them correctly. That is the number you actually want on a def loop. And now you can prove it instead of hoping. So now you can write an agent from an empty file and you know exactly which part is the agent. It is the loop. You have a harness that tells you when it works and more importantly when it quietly doesn't. And you have a number instead of a feeling. Those were 50 questions with a temperature 0 on the simplest agent anyone can build. Next step. Point this harness at whatever agent you are already running at work. Run it 50 times and look at the spread. And if you want more stuff like this, hit subscribe. I'll catch you in the next one.